how to identify the magnetic field pattern due to a straight current carrying conductors when they are placed parallel to each other and very close to each other. Just observe the figure 1. Here, these are the two straight current carrying conductors in which a direction of current is the same, bottom to top. When current direction is bottom to top, then when we apply the right hand thumb rule, we will know that magnetic field is around it in anti-clockwise direction. That's a very good point. And for a straight current carrying conductor, field will be in form of concentric circles that we already know. So field pattern is concentric circles, that's fine. But what is the direction of magnetic field? For direction of magnetic field, I'm applying right hand thumb rule, and then you realize that magnetic field is, when you apply the right hand thumb rule, it will be like this. And for the second conductor, it will be like this. That means you see, between the parallel conductors, magnetic field direction is completely opposite. So for the first one, field is in this direction, second one, field is in this direction. That means magnetic field totally cancel each other. So in that case, how to understand the pattern? So in between, the magnetic field strength is completely zero when the conductors are placed parallel to each other and current direction in both of them is same. So between them there is no field, that's fine. So around the straight current carrying conductor, very close to the conductor, there is magnetic field, but as the distance increase, the field will start running from one conductor to the other, and direction same, you can apply the right hand thumb rule. So when you apply right hand thumb rule, you realize the field is in anti-clockwise direction. So it will travel all the way from one conductor to the other conductor, and it runs from one conductor to the other conductor, and in between the conductors, where I'm just scribbling with red, there is no magnetic field at all. So between the conductors there is no magnetic field, but field runs from one conductor to the other. For the two straight current carrying conductors, when current direction is opposite to each other, so the magnetic field is in form of concentric circles as I'm drawing. And for the first conductor in figure 2, the direction of magnetic field is in anti-clockwise direction, and for the second conductor, the direction of magnetic field is in clockwise direction. Now if you observe that in between the conductors, field direction is the same for both the conductors. So the field direction is the same direction. So field is strong if the direction of current in both the conductors is different. So in the first case, between the conductors, magnetic field intensity or magnetic field strength is 0. No magnetic field. The fields cancel each other. But in the second case, the magnetic field strength between the current carrying conductors, where current in the two conductors is opposite. So magnetic field is the strongest.